Kitchen science. Kitchen science. The stove can be your favorite appliance. Kitchen science. Make some slime. Make some goo. Just a few things that you can do.
Hi, I'm Dr. Michelle Dickinson, and science is my thing. What's great is that science is all around us, and you don't need a big scientific lab or even expensive equipment to have fun with it. Welcome to Kitchen Science. This is where I'll show you how to perform real science experiments using everyday ingredients that you can find in your very own kitchen at home. Today, we're going to have fun with eggs and 2 experiments. I know. If you drop an egg, it will usually crack, but with our first experiment, you're going to see it actually bounce. And then I'll show you how to squeeze an egg into a bottle using only the power of air pressure. But first, it's time to meet my very special lab assistant, that's Cooper.
Hi.
Would you like to do some science today?
Yes.
Do you like eggs?
Not really.
Not really, that's good. We're not going to have to eat the eggs today, we're just going to experiment with them. Now for this experiment, we're going to need a glass or jar, an egg, and some white vinegar. Take a look at this egg. If I were to drop this egg onto the table, what do you think would happen?
It would splat.
It would splat because the eggshell is very brittle and it cracks easily, yeah? And the inside of the egg is runny, like a liquid. We're going to turn this into an egg that you can bounce on the table without it going splat. Does that sound cool?
Yep.
Okay, what I need you to do is open this jar for me and carefully put the egg inside. Next, we're going to fill the jar so that the egg is covered with white vinegar. Perfect. Now, we're going to put the lid back on the egg and the jar. And let's take a look. So if you look at that egg, can you see something happening to the eggshell? What's forming on the eggshell?
Bubbles.
So we can see all the bubbles now sticking to the side of the eggshell. And that's because a gas called carbon dioxide is forming on the surface of the egg. And that shows us that a reaction is happening, a chemical reaction. Now we're going to leave this for 4 days. How much time have you got? Not 4 days. Okay, good. Luckily, I have one that I made before. So can you see if it looks different to your fresh egg?
The shell is peeled off.
Is it a bigger or a smaller egg?
It's a bigger egg.
Now I promise you, when I put this in 4 days ago, it's the same size of egg that you had. Now we know that the shell protects an egg. And so what's really interesting here is because the shell is made out of something called calcium carbonate, which is very hard, the acid in the vinegar dissolved that away. So the inside of the egg was left unprotected. Now here's the fun bit. Put your fingers in and see if you can wipe the shell away.
Whoa, it's like so soft.
Let's pull the egg out. And so you're actually holding the inside of the egg that would normally be a liquid. And we have turned it into a solid by denaturing the proteins with the acid. Now remember, when we said you drop a normal egg, the inside of the egg will go
Splat.
splat. So here is your test. Drop it and see if it breaks. What's it doing?
It's bouncing.
So that is the inside of the egg that you have now made into a bouncy egg. Is that fun? Does it smell? That's experiment 1. You have another experiment to go, which is called egg in a bottle. Now for this experiment, we're going to need a glass jar or bottle, candles, matches or a lighter, a saucepan, water, and a banana and an egg. So first you're going to take your jar and make sure it's the right size. So put your egg on top of the jar. Does it fit?
No.
That's the right size. If it falls in, then your jar mouth is too big. Next, we're going to take this egg and we're going to boil it. We want a hard-boiled egg, so that's 8 minutes. Okay, so we're going to go over to the pan, and luckily, I have an egg that's been boiling and should be nice and hard. Now, how good are you at peeling eggs?
All right.
Well, there you go. You get to peel that one. Great. While you are doing that, I'm going to make a base. And you don't need to use a banana. I like it because it's edible, but you can use some plasticine or some dough. Next, you want some candles. I like 3 birthday candles, and I'm going to put those into my banana. So we have a nice little peeled egg. And let's check, does it fit inside our bottle? Place it over the top. No.
Nope.
So our goal is to get that egg into the bottle. So the way we're going to do that is we're going to use fire. We're going to drop these candles into here. Okay, now you can either use a lighter or some matches. So this is an adult part because we have fire here. So we're just going to let them burn a little bit, and that's going to heat up the air inside here. Now, have you heard of the fire triangle before?
No.
So the fire triangle is what fire needs to burn. It needs three things: fuel, which is the wax from our candle, oxygen in the air around us, and it also needs an ignition source. Now, as it burns, it's going to make the air inside this jar warm. And warm air takes up way more space or volume than cold air. Now, what's going to happen is we're going to put the egg on top that's going to seal the jar. And when we do that, we're going to cut off the oxygen supply. And be careful you're not going to burn yourself. Put the egg over the top and let go. Ah. You see the flame's gone out?
And the egg is going down.
And what's happening is the air is cooling down in here because the fire went out. And the fire went out because we used up all the oxygen in there. And what happened is, as the air cools, it takes up less space. And so the air from the outside tried to suck more air in from the atmosphere. It couldn't suck in more air because there's an egg in the way.
Yep.
So that's how you get an egg into a jar. Is that cool?
Yep.
Did you have fun?
Yep.
Give me a high five before you go. Thank you, Cooper, for helping me. I'll see you next time.
Yep.
For more crazy and cool science recipes you can make with stuff you can find in your very own kitchen at home, join me here next time on Kitchen Science.